Welcome to Theory of Computation, popularly known as TOC. So this is very important subject for GATE examination. The weightage for GATE will be around 8 to 16 marks. So earlier when the GATE exam used to be of 150 marks, that time the weightage for this course was around 20 to 25 marks. So it's very important subject. Now they ask around up to 8 to 16 marks. So let me introduce myself. My name is Ganesh Patil. I graduated from IIT Madras and I am currently working as a software engineer at Intel. So let's have a look at syllabus for GATE exam of TOC. The first one is finite automata and regular language. The second one is push down automata and context sensitive language. The other one is context free language. Third part is recursive enumerable sets and Turing machine. The last part is undecidability. This is the most important part. So around 60% questions you can expect from finite automata and regular languages. This contributes to, let's say, 20% and this contributes to 20%. So TOC is quite interesting subject, although it's a part of mathematics and theoretical computer science, but still it's independent of all the subjects, I can say. You don't need any prerequisites for that subject. So in engineering, if you haven't done any subject properly, this is the best chance for you. This is independent, so you can just start concentrating on this subject, and you don't have to mug up anything. You don't have to remember any formulae or as such. It's just we will put some automatas and some algorithmically they will be satisfying the criteria of our conditions. That's all. So let's get started. So reference books. One is Ullman. The other one is John Martin. Misra and Chandrasekhar. And fourth one is Sipser. But frankly speaking, you don't have to go through all these books because only our class material should be enough for GATE and even for your university exams. So theory of computation is a mathematical representation of a computing machine and its abilities. It's a mathematical representation of a computing machine and its capabilities. So machine here is not the machine which we found in motors or anything else. It's a computer machine, and it will be of this sort. So there will be some transactions, and these are all called states, and how do we go from one state to another state. So this is the machine. So what does this machine does is it processes the language. Now, what is the language? Formal language. Formal language is a collection of strings where the meaning of the string is not important, but the format of the string is important. So format in the sense any language any language will have some form. For example, English we have subject, then verb, then object. So similarly in TOC there will be some format of the strings. So this format is important, not the meaning. For example, A, B, B. This is one format in TOC of some language. So this format is important. The meaning is not important because we don't care about this meaning. But the format, like 2 A's after that 2 B's should come. Then it will be recognizable. So language has 4 types. Type 3, Type 2, Type 1 and Type 0. So Type 3 languages are called regular language. Regular languages. So let's say regular languages. Type 2 are context-free languages. Type 1 are context-sensitive languages. And type 0 are recursive enumerable sets. Or they are also called as unrestricted language. We will get into the details of these languages later. So as of now, just remember that these four are the type of languages, and the regular languages are accepted by finite automata. Context-free languages are accepted by push-down automata. push down automata. So finite automata is generally referred as FA. Push down automata we can write as PDA. Context sensitive languages are accepted by linear bounded automata. So the acronym is LBA, and these languages, type 0 languages, are accepted by Turing machine. Abbreviated as Turing machine. So in reality, linear bounded automata doesn't exist, and Turing machine is a hypothetical concept which can solve all type of problems, which can recognize all the languages. That is the Turing machine. So if we see the relation among them, it is like this. So type 3 language is a subset. Type 3 language is a subset of type 2, is a subset of type 1, and type 1 is subset of type 0. These are regular language, is a subset of context free language, which is subset of context sensitive language, and type 0 is above all. So diagrammatically we can present them as like this. Type 3 is a small subset. Type 2 is bigger one. Even bigger than that is type 1. And finally type 0. So type 3 is regular language, type 2 is context free language, type 1 is context sensitive language, and type 0 is unrestricted language. Let's say unrestricted language. So now expressive power of a finite automata. This regular language is accepted by finite automata. Context free language is accepted by push down automata. Context sensitive is accepted by linear bounded automata, and unrestricted language is accepted by Turing machine. So expressive power of an automaton. So automaton is a singular form of automata. Automata is plural form and automaton is singular form. So what is the expressive power of automaton? An automaton. So expressive power means, for example, I can express myself in 3 languages: English, Hindi, Marathi. So my expressive power is 3. For example, you people can speak your native language also, so you can add that. So your expressive power will be 4. So in the similar way, the expressive power of finite automata. So expressive power is the number of languages accepted by that automaton. These are the number of languages accepted by the automaton. So expressive power of finite automata, we represent it as E of finite automata. That means expressive power of finite automata. Expressive finite automata can recognize only regular language. So expressive power is 1. Expressive power of push down automata. So since push down automata is it encapsulates the finite automata as well, so it can recognize context free language plus regular language. It means it can recognize two languages. So expressive power of PDA will be 2. Now expressive power of linear bounded automata. So it can accept context sensitive, it can recognize context free, it can recognize regular language also. So expressive power will be 3. What is the expressive power of Turing machine? It will be unrestricted language, context sensitive, context free, regular. So expressive power is 4. So in terms of expressive power, we can write the relationship as in terms of expressive power. In terms of expressive power, finite automata expressive power is lesser than push down automata, is less than linear bounded automata, less than Turing machine. So it means Turing machine stands at the highest level because it can encapsulates all these type of languages. So Turing machine is the most powerful machine.